candidates. Something weird is going on, and this party seems to be completely unheard of. Of course, the prevalent theory is that this is a front for some money laundering or some other party trying to disrupt the votes. You may have seen the case of the 11 Chandulal Sahus in Mahasamud this year. It was a remarkable strategy. In no past election has there been ever since 1970, after 1981, there has been no election where another candidate has had the exact same name as a leading candidate, the previous winner. It has happened this time. But not just in one place, in 17 constituencies. Not only that, in Mahasamud, there were 11 candidates called Chandulal Sahu, who was the last year's MP. Now, what is also interesting is that in every single case, the earlier year's winner was from a party other than Congress. In other words, there was no confusion among the people that were voting for Congress. It was only confusion for people voting for other parties. Now, I'm not implying anything. I'm just saying that this is an interesting observation that happened this year. Or, let's take all of this. Let's ask the question, what is the largest number of candidates that you think ever stood for elections in a constituency? 1,053. An interestingly accurate number. Do you have an idea of where it was? Sorry? Tamil Nadu. Close enough. That's actually Modakurichi, and it was 1,033 candidates that stood for elections. See, at this point, when you have 1,033 candidates, you don't have a ballot paper. You don't even have a ballot booklet. You have a ballot book. More realistically, a telephone directory. Just pass them and say, look, pick the guy you want and make him the MP kind of a thing. And the weird thing is, if you look at the names, I mean, how do you even distinguish between Palanisamy C, Palanisamy C, Palanisamy C, Palanisamy C, Palanisamy C? So, given the numbers, you've got to start telling people, I'm Palanisamy C number 734. Now, in these cases, many of them just got one vote, which was them luckily finding out who they were and voting. But there were as many as, unfortunately, this is getting cut off, there were as many as 88 candidates who got 0 votes. Either they couldn't find themselves, or they didn't bother voting. So what happened in this particular election remains a complete mystery. What I'm leading you to is data has changed what we look for. Data has changed the way we approach testing. Two things have happened. What we test increasingly involves more volumes of data, and we are often helped by this volume of data. Specifically, we used to test code, now we also test data. We used to find errors, now we are looking for patterns. We are looking like an analyst to see what is weird. And the incredible bonus of this is that either you find an error or you find an interesting observation. It's almost like a no-lose situation. You have to win in this if you're able to spot a pattern. Lastly, what was automation? Applying code to fixing code is now moving to machine learning, applying data to fix data. The examples that I gave where, for example, you take a specific word and look for alternate spellings of that and automatically correcting it based on the most frequent one is a simple example of machine learning. Simple conceptually, but extremely tough from an implementation perspective. But the good part is this base is good. And we are at a stage where the movement is clearly from the left side to the right side. Not to say that the left is decreasing, but rather the right is increasing faster than the left is. And what I want to leave you with is a thought that you probably want to take a look at data testing. You probably want to take a look at testing using data and see where that leads your careers. Brief word about us. Grammar is a data visualization and analytics company. Giving you some examples of our work. More examples of our work are at our website. My contact details are here. Please feel free to reach out at any point. We are recruiting as well. And if you want any more details, examples, thoughts of how this can be applied in a testing context, again, more than happy to reach out. I don't know if we have time for questions.
Let's take.
Okay, maybe we can take it if you have any questions.
The method we use for, we'll see which is the more frequent to see whether it's error in spelling. Yes, this is the most, which I think, is there any other way also, because in some cases it may not be right.
Okay.
So what are other ways of like making sure that it is...
I get asked this question very often, and what I find is that there is what is called a central limit theorem, which is a very interesting theorem. It says that, the question is, we've looked at, say, Bhadrachalam's 2 spellings and we've taken the most frequent one, but that is not always correct. Can we do something better? And I was commenting that there's something called a central limit theorem in statistics, which is a very interesting theorem. It says that, look, if I take a large population and I do a sample out of it, the percentage size of the sample is not too important, it's the absolute size that is important. Meaning, if I have, let's say, 100 ball bearings and I pick 10% of those and I do some tests on it, that is somewhat accurate. If I take 10,000 ball bearings and take 10% of it and do some tests on it, that's far more accurate. It is not the percentage which has stayed constant that matters, it is the absolute underlying numbers that matters. And the thing about big data is that given the volume of data, if you pick a sample and start applying that, you tend to find the results to be extraordinarily accurate. Let us take a specific example. If we take marks, okay, how many people think boys score more than girls on average? 1, 2, 3, 4, 5, 6. This is a very bold group. This is the highest number of hands that I've seen lifted in any audience of any size. Okay, how many people think girls score more? Okay, you're all right. On average, girls score more, any which way you slice and dice. There are a variety of explanations for it that I'm not going to go into. Nothing to do with ability or anything. It's more to do with dropout ratios and stuff, a bunch of other stuff. But, so when you test this hypothesis, you can actually find out how likely is this to be wrong. There is a measure of statistical significance. The chance that this is wrong, at least in India, where we've done this analysis, is less than 1 in 10 to the 23. Now that is approximately trillion. With that kind of accuracy, you can be reasonably sure that these kinds of things are not wrong. Now what happens is, if we say that there's a small chance that people will give the correct spelling more, and only a small chance that people will give the wrong spelling less. That small chance with this kind of large data amplifies to the point that the larger the data you have, the more accurate the results are. So therefore, the short answer to what would we do if we want better accuracy, is there any other technique, is simply increase the volume of data, increase the base, and the problem in itself rectifies. The research director of Google, Peter Norvig, put this extremely well. Google Translate works on precisely this principle. Google spelling corrections works precisely on this principle. And it is remarkably accurate because as Google's corpus grows, this grows too. So, short answer, throw more data at the problem.
Are there any tools for correcting the spelling mistakes on database?
Are there tools for correcting spelling mistakes on a database? What I showed first, spelling mistakes, yes, several. And this has been there for a very long time, using effectively a dictionary approach. In the sense that here are a set of words that are in a dictionary. You take a word, you identify how close it is to that particular word. If it is within a certain distance, it is automatically corrected. If it is within the next page, then it is flagged for correction. And if it is beyond that, it is not marked. I'm not going to go into the names of these tools specifically on a database, but on Unix, for example, you can just export it. And there is a command line tool called spell, which applies it for several gigabytes or terabytes of data, and you can re-import it back. It's not a problem. But
my question is, in the banking database, if you have address, is there any automatic tools for correcting the address of the database?
spelling mistakes are very different from addresses. Here's the thing. Are there any automated ways of correcting it? Yes. Are there any out-of-box tools that you can just go by that will fix your address? There is that difference. Now, why is that a problem? The reason that is a problem is because the structure of addresses are reasonably complex. Now, what constitutes the distance between two words from a spelling mistake perspective is not what constitutes the distance between. So, let us take an example. We are now at Sankey Tank Road. Now, if I say Sankey Tank Road, Bangalore, and another person says Sankey Tank Road, Hyderabad, if there is one such. Now, these are nowhere near each other, but the spelling is pretty close. Almost every tool will say these two are candidates for merger because about 60-70% of the word is exactly the same. So how does one go about that? One writes an application that walks through the structure of the data and modifies it. Are there people capable of writing these applications? Several. Are there any out-of-box tools that in an Indian database corrects it? In a US database? Not. I'm not getting into specifics of the nature of tools because these are all niche tools and all of them get updated very quickly. But spellings are very easily correctable and have been very easily correctable for a long time using a dictionary-based approach. And increasingly, we are getting towards a data-driven approach as well, where it looks not just at global spellings, but your own data spellings and starts correcting those.
I have one question with the format of data.
Sorry?
Format of data.
Format.
We are only talking about like CSV files or flat files. So how about the data getting from some social media and all the
The question is, what about format of data? The good part is, let's take data from social media. Is very comfortably placeable in an Excel file. Let us take SAP's NetBase, which scans social data and provides an API to export it. What format do they allow you to export it? CSV. Let us take Radian 6, exactly the same. Now, why is that? Because ultimately, we have data in the social media that is streaming in constantly, and every unit of data is a row. Now, this data has various attributes. Now, some of this is hierarchical. So you say, I want to see the user's attributes. So for a user, there is a name. So under user, you have a bunch of characteristics. Under the tweet, you have a bunch of characteristics. One of those elements of the tweet is a user. So you have a two-level hierarchy. But all of this can be flattened and placed onto a bunch of columns. I have 500 columns. So be it. The columns have a relationship. So be it. But it's still structure. So A, we do not need to worry about the difference between hierarchical and non-hierarchical data when it comes to data of this scale. It is all equally easily processable using tools today. There are, however, exceptions from two perspectives. One, your input data may be unstructured. In a sense, let us say I take the Mahabharata and I want to do an analysis on it. You will in fact find an example of this on our website. How does one go about doing it? Now here I have text. I don't have any structure. Can we infer structure from this? And the short answer is yes, quite easily. And there is a mature field right now called text analysis that does a lot of things in this space. The other problem that we have, apart from unstructured input, is the unstructured relationships between data. You saw the network of Tata directors versus their company. Right? Now that's not quite tabular data. That is more like a network relationship. And there is a fairly mature field today called network analysis, which talks about how we can take that kind of non-linearly structured data and analyze it like linearly structured data. So both text analysis and network analysis have gone to the point where we can transform unstructured data and unstructured relationships into structure. And that is pretty much the way most analysis or most handling of unstructured data is progressing today. That is, you figure out a way of converting it into structure and then you apply all of the tools that you have for structure. This is not always possible. For video, for instance, we are still struggling. And computer vision has only gotten to a moderate point of being able to do that conversion. Audio recognition has been stuck at this stage for a long time, and it's only now that we are again making improvements. But text analysis and network analysis have gotten to the point of what I would call maturity. So, short answer, if you have any kind of unstructured, hierarchical, non-tabular data, figure out a way of converting it to tabular, and it is almost always possible.
Any further questions?
The complete interpretation of the data has been reversed or changed.
By invalid, you
By
mean?
making them, by not considering that it's not part of the data.
Yeah, several. But that is okay. Let's take an example. Okay. So one of the weird things that we found was, let me take the marks data. And we found a curious thing. In South India, all North Indian surnames do extremely well. The average marks in South India is about 66%. The Jains on average have an 84% average. Shahs 85%. Agarwal's 88%. This is like 3 sigma levels, which is very unusual. Now, why is this happening? A reasonable number of socioeconomic reasons. I mean, it's more likely that someone who migrated from the north to the south is economically more well off than someone who is in the south. In fact, if you look at the names of people that have the lowest marks on average, Manigandan, Murugesan, Thiruvannamalai, hardcore rural names. Now, which again is not to say that the name affects the marks. It is just saying that the same factors that affect the names, which is socioeconomic background, are factors that are correlated with the choice of names as well. Now, if you take off all the North Indian surnames out of India, or if you take all of the urban names out of India, you get a market distribution. What you find is that girls on average do not score high. In urban areas, girls in fact have I would say girls on average score the same as boys. Whereas in every rural region that you look at, boys score much more than girls. Now, we know why this is. This is because of the dropout ratio. In rural areas, the girls' dropout ratio is higher, so which means that it's more likely that a girl who's studying well is likely to stay back in school than a girl who's not studying so well. In urban areas, there isn't much of a difference in the dropout ratio, so this doesn't really impact the average scores. So in this case, the conclusion, if we were to look only at, if we say, I'm going to look at, let's say, all private schools, which is one subset of the data, and invalidate your state board schools data, for example, or public schools data, then you get a very different result from what you had earlier. So this is, I would put it as a subset of segmentation. Different segments have different results. And if you invalidate data and that knocks off a big chunk from one segment, you almost necessarily have a different conclusion if that segment had an impact on that data. Which is also why sampling randomly is important. If you were to say, I'm going to pick the top 1,000 rows, and the top 1,000 rows happen to have names that start with the letter A, that is a bias sample. In fact, there's no way of removing bias other than random sampling. Yes, we are out of time, so I'm going to stop the questions here. We can always talk offline. Thanks a lot for your time.